Hi everyone, we're back on our second video underneath the title of Unit 2, Derivatives. And we're going to start, and the only example in this video is going to be example 1 in your packet, part A. We're going to take this step by step. And this example says, find the slope of the tangent line. Okay, so let me highlight that. That's the derivative. Find the slope of the tangent line, aka derivative, title of the chapter, to the graph of f of x equals x squared minus x. So this guy right here is going to become super important. Okay, before we even start, I'm a visual person. You guys know this about me. I want to graph, and by the way, I'm not drawing this right on my note sheet. I have an extra sheet of paper here. So if you want to put this into your notebook separately, or maybe make it really small off to the side, this space I need for something else. But right now, I'm going to be graphing this quadratic function. Now, in Algebra 2, this is a bit of a review. In Algebra 2, you learn some key points to help you graph a parabola. Those points were your y-intercept, your x-intercepts, and your vertex. And this was to graph functions that were in the form y equals ax squared plus bx plus c, your quadratic family. So we're going to do the same thing. So in order to graph this, we are going to start by finding the y-intercept. So let's do that. So the y-intercept is the value of y when x is 0. So by now you know to find a y-intercept, you just find f of 0. And f of 0 is just going to be 0 squared minus 0, which is 0. So your y-intercept sits at 0, 0. When x is 0, y is 0. So I'm going to fill that in over here, 0, 0. Okay, your x-intercepts are the values of x when the y value is 0. So you set your function x squared minus x equal to 0 and you solve. You can factor out an x and you're left with x minus 1. You set both of these to 0. And when you do that, you're going to have x equals 0. So that's one of your solutions. Or if you set x minus 1 equal to 0 and solve, you're going to get x equals positive 1. So your two x-intercepts are 0, 0 and 1, 0. Well, we already have 0, 0 planted from the y-intercept, so 1, 0 we're just going to put right here. And last but not least, the vertex. In Algebra 2, you learned a formula to find the x value of the vertex. Its x equals the opposite of b over 2a. So filling that in, now remember, a is the coefficient in front of x squared, b is the coefficient in front of x, and c is the constant at the back. We don't have a c in our formula, so you don't have to worry about that. But if we go up to our function, a is 1 and b is negative 1, and of course the c is 0. So when we fill this out, the opposite of b, well, b is negative 1, so the opposite of that is positive 1 over 2 times a, which is 1. So the x value of the vertex is a half. Now, because my x-intercepts are nice integer values, I know that the vertex lies halfway between. So I could have seen that from up here, that halfway between 0 and 1 is a half. And then to get the y value that goes with that, I simply do f of 1/2. And if I plug 1/2 back up here, I've got 1/2 squared minus 1/2, which is a fourth minus a half, or negative 1/4. So my vertex sits at 1/2, negative 1/4. And that's going to be just barely below the x-axis there. And so now I open my parabola upward with my positive a value, and here is my graph. Now, why did I do that? Well, I'm visual. For my visual learners, I think this is going to help when we go to do our derivative. The key idea here, guys, is this. When we do this derivative in just a minute, it's going to find us the slope anywhere along here. So like say you x off like this point right here, and this is your P. If you follow the contour of this curve and draw a tangent line, it's going to have a negative slope. If you come down here and let this be your P, your fixed point, and do a tangent line, oh, it's still going to have a negative slope, but not as steep as I am here. If I come over here to the right side, let P be over here, if I draw a tangent line, oh, it's going to be a positive slope, much different from over here. If I come down here to this x-intercept, not quite as steep. See how the slope varies. This is what's different between linear functions and quadratics or any other curve. On anything that's not linear, the slope is going to vary as you move around it. That is why when we do our formula, see, let's go back here now. When we have our formula, slope of the tangent at x f of x, see, this is generic. We have to open this up to wherever the heck we want to go, is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. This is the formula we're going to use, but now what we're going to do is make this specific to this quadratic that we just graphed. Okay, so step 1, write the formula down. We've got that. Okay, step 2, I like to call this my side work. Now, not everybody needs to do this, but I have found it to help students along the way, so I'm going to show it. So my side work. What I like to do is look at this numerator. See how it has 2 parts? It's got the f of x, but it also has the f of x plus h. Here's what I'm going to do. F of x is easy because it's the given function. I'm just going to copy that down. F of x is x squared minus x, okay? Now, I can do a lot of things with this. I could do f of 2. If I do f of 2, what do? Well, I put 2 squared minus 2. I just took a 2 and put it where the x was, both of them. If I'm going to do f of negative 5, f of negative 5 would be negative 5 to the second power minus negative 5. See, wherever there was an x, I replaced it with a negative 5. If I do f of smiley face, that's going to equal smiley face squared minus smiley face. See the pattern? Now, this is what gets students every year. So if I'm going to do f of x plus h, don't let this freak you out. Okay, so wherever x is, x, 2, 2, 2, negative 5, negative 5, negative 5, smiley face, smiley face, smiley face. Well, guess what? When you're doing f of x plus h, you're going to replace all the x's with x plus h's. You already did the first one, boom. F of x became f of x plus h. Now, this has to become an x plus h, and this has to become an x plus h. So it's going to look like this, parentheses, x plus h squared minus parentheses, x plus h. Don't split them up. Don't split the x and the h up. Just take it as one unit, in for here, in for here. Replace, replace. Put it in parentheses. Wherever the x is, you put x plus h. Wherever the x is, you put x plus h. And then do unto the x plus h whatever was being done unto the x. Okay. Now, we're going to click and drag this information back to our problem. We need f of x plus h. That's right here. And we need f of x. That's right here. Okay? So bring it on back. You don't have to recopy this every time, just the limit part. I know what you're finding now. You're finding the slope of the tangent anywhere. So now we have the limit as h approaches 0. Okay, down here, this is f of x plus h. So x plus h squared minus x plus h. That's this part. That's this. Minus. Look at how I'm going to exaggerate that minus. This is the minus in the formula. Now, f of x is right here, and I'm going to put that in parentheses, x squared minus x, because it's a binomial. And I know this negative is going to have to distribute. And this is all over h. The rest is history. Listen, go back to Unit 1. The rest is just a limit. What's the first thing we do with any limit? We plug it in. If you plug 0 in for all these h's, look what you're going to get. You're going to get x plus 0 squared minus x plus 0 minus x squared plus x. See, I'm distributing that negative all over 0. Well, look what happens. This is x squared, which cancels out this negative x squared. This is negative x and positive x. So you end up getting 0 over 0, which is undefined. Well, we know what to do with that. We do something algebraic to make things cancel out so we can manipulate the problem. So go back here, go back to this step right here, and you can see some algebra that needs to be done. You can FOIL this quantity. X plus h to the second power means x plus h times x plus h. So if you FOIL that, you're going to get x squared plus 2xh plus h squared. If you take the next part and distribute the negative through, you're going to get negative x minus h. And if you distribute this negative through, you're going to get negative x squared plus x. And this is all over h. Now look what happens in the numerator. Things start to cancel. This x squared right here goes out with this negative x squared. This negative x right here goes out with this positive x. And so up top in the numerator, you're just left with 2xh plus h squared minus h all over h. And what's great about this is, do you see how if we factor out an h in the top, like a GCF, take an h out, you're left with 2x plus h minus 1 all over h. And then these h's cancel. And the last step is just to plug it in again. So if you let this h be 0 again, you've eliminated, look, there it goes. There went the 0 over 0. So you just have 2x plus 0 minus 1. Final answer, 2x minus 1. And now here's my last question. So this is the derivative of this function. Anywhere. This is the derivative of this given function anywhere. Why is there an x in it? Why is there an x in it? I know this looks like the equation of a line. It's not. This is just a slope. This has nothing to do with the equation of a line. This is a slope. I know it looks like mx plus b. It is not. This is just the m. Why does it have an x in it? Well, go back to your picture. It depends on where you are. Look, if x is negative 2, if you plug negative 2 in here, put a negative 2 in here. 2 times negative 2 minus 1 is negative 5. That just means that this slope is negative 5. That's m. If you change it, if you go over here to positive 2 here, change this to a positive 2. 2 times 2 minus 1, that's 3. That means the slope here is 3. See how you need the x there to move around? The slope depends on where you are on the x-axis. It's beautiful. So now you can go anywhere along this parabola you like, and you're going to find the slope there. Even if you go, check it out, if you go to the vertex at a half, look at this. 2 times a half, put a half in there. 2 times a half minus 1 is 0. That's why you have horizontal tangent lines at vertices. So cool. So we went from a negative slope to a 0 slope to a positive slope, all by changing what we plugged in here for the x. So a lot of times, unless your function is linear, listen, if you have a linear function, the slope will be consistent throughout. You won't have an x here. You'll just have a number. But that's the only time. If your function is nonlinear, quadratic, cubic, quartic, trigonometric, exponential, you're going to have an x in the derivative because you need mobility and you need to be able to have that slope changing. All right, thanks for watching. Our next video is going to cover B, C, and probably example 2. All right, so stay tuned.